In a previous video, we introduced ourselves to the idea of bonds and the idea of ionic bonds, where one atom essentially is able to take electrons from another atom, but then because one becomes positively charged and the other becomes negatively charged, they get attracted to each other. Now we're going to go to the other end of the bonding spectrum, where instead of stealing electrons from each other, we're going to share them. Let's say we're dealing with two oxygen atoms. So let me draw one oxygen here. A neutral oxygen has 8 electrons total, but 6 of them are in its outer shell. So it has 1, 2, 3, 4, 5, 6 valence electrons. And the way that I arrange them is I paired them up last. So you have these 2 valence electrons that are not paired with another electron. And now let me draw another oxygen, and I'm going to do it with a different color so that we can keep track of the electrons. So another oxygen right over there also has 6 valence electrons. 1, 2, 3, 4, 5, 6 valence electrons. Now, this oxygen on the left, in order to become more stable, it would love to somehow gain or maybe share 2 more electrons. And of course, this oxygen on the right, it's still oxygen. It also would love to gain or share 2 more valence electrons. So how could it do it? Well, what if the oxygen on the left shared this electron and this electron with the oxygen on the right, and the oxygen on the right shared this electron and this electron with the oxygen on the left? Well, if they did that, you would have something that looks like this. You have your oxygen on the left, you have the oxygen on the right, and the way we show 2 electrons that are being shared, let's say these 2 electrons are being shared, is just a line like this. This shows that there are 2 electrons that are being shared by these 2 oxygens. And let's say that these 2 electrons are also being shared. You would do that with a line like this. And then we could draw the remainder of the valence electrons. This oxygen on the left had, outside of the electrons that are being shared, it had 4 more valence electrons. And then the oxygen on the right had 4 more valence electrons. 1, 2, 3, 4. Now, what's interesting here is these shared electrons, these are going to cause these oxygens to stick together. If they don't stick together, these electrons aren't going to be shared. So what we have formed here is known as a covalent bond. Covalent bond. And what's interesting is it allows both of these oxygens in some ways to be more stable. From the left oxygen's point of view, it had 6 valence electrons, but now it's able to share 2 more. Remember, each of these bonds, each of these lines represent 2 electrons. So this oxygen could say, hey, I get to have 1, 2, 3, 4, 6, 8 electrons that I'm dealing with. And the same thing is going to be true of this oxygen on the right. Now, there are some covalent bonds that are between not so equals. So for example, if we're talking about water, and if we're talking about how oxygen bonds with hydrogen. So if we have oxygen right over here, once again, I can draw it 6 valence electrons. 1, 2, 3, 4, 5, and let me just draw the 6th one right over there. And if I have hydrogen, hydrogen has 1 valence electron. So let's say that's a hydrogen right over there with 1 valence electron, maybe another hydrogen right over there with 1 valence electron. Oxygen and hydrogen form covalent bonds. In fact, that is how water is formed. And so what would that look like? Well, it would look like this. You have oxygen right over here. You have these 2 pairs of electrons that I keep drawing. And then this electron right over here could be shared with the hydrogen, and that hydrogen's electron could be shared with the oxygen. So that forms a covalent bond with this hydrogen. And then this electron from the oxygen can be shared with the hydrogen, and that electron from the hydrogen can be shared with the oxygen. And so that would form a covalent bond with that other hydrogen. And now here, once again, oxygen can kind of pretend like it has 8 valence electrons, 2, 4, 6, 8. And the hydrogens can kind of pretend that it has 2 valence electrons. But the one difference here is that oxygen is a lot more electronegative than hydrogen. It's to the right of hydrogen. It's in this top right corner outside of other than the noble gases that really like to hog electrons. So what do you think is going to happen here? Well, the electrons in each of these covalent bonds are going to hang out around the oxygen more often than around the hydrogen. So if the electrons spend more time around the oxygen, you're going to have, in general, more negative charge around the oxygen. And so you're going to have a partial negative charge on the oxygen end of the water molecule, and then you're going to have partial positive charges on the hydrogen ends of the molecules. And in case you're curious, that little symbol I'm using for partial, that's the lowercase Greek letter delta, which is just a convention in chemistry. And so this type of covalent bond, because there is some polarity, one side has more charge than the other, this is known as a polar covalent bond. Polar covalent bond.